Welcome to our manufacturing tour here at Trelleborg Stein am Rhein. My name is Caroline and I will guide you through the tour today. So let's go inside. Now we will meet our general manager, Jano. Hello.
Hello, Caroline.
Jano, what can we expect to see during the tour today?
In today's tour, we're going to show you all the value-adding processes which we are accommodating here in our Center of Excellence in Stein am Rhein. This starts from the initial inquiries, feasibility analysis, simulation, automation, tool making, process, the entire value chain resulting into quality aspects and finally validation. We will show you our entire capacity, capabilities in the tool making, in the engineering, in the manufacturing, which also include our clean room operations where we accommodate very challenging and demanding parts in the healthcare and medical industries.
That sounds really exciting. Thanks, Jano.
Okay, let's do the tour then.
Our first stop is our engineering department. This is also the first point of contact for our customers in case of technical RFQs. Hello, Jerome. Can you please give us an overview of the engineering?
Hello, Caroline. Of course. This is where customers' ideas become reality. We have a team of design and project engineers who act as the technical interface to our customers to evaluate the feasibility of their requirement. The complete engineering department has around 35 employees and includes also the tool shop, which we partly see later.
That sounds really interesting. Thanks for the overview. What do you see as the main tasks of the department, and what is the interaction with the broader Trelleborg team and for sure with our customers?
We collaborate closely to our experts from R&D in Trelleborg Stuttgart to evaluate a DFM, a design for manufacturing analysis. This is how we ensure from the beginning that the design is liquid silicon rubber friendly and also as simple as possible to manufacture.
That sounds as a really good added value for our customers. Do you see additional things we can offer to our customers to support them?
Yes, there is one important thing and also key factor to the business. This is our well-educated team of highly experienced engineers. All employees are working here in-house in Stein am Rhein. We offer our customers the technical support from the beginning to the final SOP. For that, we operate with state-of-the-art technology, software, including mold flow simulation.
Thanks for the insight, Jerome. Really interesting. You mentioned the tool shop. Can we have a look?
Yes, of course. Let's go.
Wow, that looks different to what we saw in the engineering department. So Jerome, can you explain us a bit what we see here?
Yes, of course, Caroline. So we are here now in our tool manufacturing. That means that we bring the drawings to life. We are building here our very high precision tools. We have other 3 tool shops outside of Stein am Rhein, but all within 50 kilometers. Here in Stein am Rhein, we are mainly focused on very high precision. So for that, we have the GEL 5-axis milling machine, and we have also the GF wire erosion and scarf erosion machines. So gives us the most precision tools.
That sounds that everything here is focused on high precision. You mentioned we have 1 tool shop here and 3 in additional. So most of our tools we build by ourselves. Can you explain a little bit more the advantage why better building LSR liquid silicone rubber tools by ourselves instead of buying it externally?
Yeah, that's a really good question, Caroline. So a big advantage of that production plant is that we have a tool shop and our engineering in-house here on the site. Especially for new tools and adjustments, this is a big advantage. And also, we do the gripper systems internally. That means we design and manufacture them in-house. With our experience of tool making and liquid silicone rubber processing, we guarantee that the gripper will demold the parts properly.
Okay, so we have a really high focus on precision, but to have a common understanding, why do we need such a high precision for liquid silicone rubber tools?
Only 5 microns will give us a flash on the part, and that could be in the end a problem for our customers. For that, we have 2 points. We have to measure our tools and we have the finishing. But let's go, I will show you the finishing.
Perfect. So Jerome, what will we see next?
As I told you that our tools are very precise, so there are more further steps, the measuring and the finishing. The measuring equipment gives us the response of the quality of our manufacturing, but you have also the manual steps on the tool.
Okay, Jerome, now when I consider all the high precision equipment we have for the tools and to create the molds, we have a manual finishing. Is that really necessary?
Yes, for liquid silicone rubber tools it is really necessary due to the high precision. So that's called the finishing.
Okay, thanks a lot, Jerome. Really interesting overview of the engineering capabilities here at Stein as well as the tool shop. And now we will go to our technical production and we'll meet Silvio there. Now we are in the technical production together with Silvio. Hello, Silvio.
Hello.
Silvio, can you give us a high-level overview of the shop floor capabilities we do have here at Stein, please?
Yes, as you said, this is the technical production with 2,100 square meter of production area. This hall is filled with 49 injection molding machines with one component and multi-component parts.
Silvio, can you explain a bit the difference between multi-component and LSR parts?
Yes, as the name already says, a one-component part is only one component. On the other side you have the multi-component parts, which is usually a combination from thermoplast and silicone. Thermoplast, silicone and color, and sometimes we even add an inlay, or in the second operation we add a diaphragm. We assemble that or apply that on the part. So our part with the most component is at the moment 4 components in one part.
Okay, that sounds really amazing and a real added value for our customers. As we are standing here before one machine, could you roughly explain the process?
Yes. Here the injection molding machine is actually producing the part. It's an 8+8 cavity tool. In the first step you make the thermoplast. In the second step you add the silicone on it. Once the part leaves the machine, on the back side is the automation, where we do a lot of assembly, quality checks, leakage tests, flow tests. The rotary table actually has 11 different stations where we do applications, assembly and quality checks.
Thanks a lot. Multi-component sounds extremely interesting. Nevertheless, could we have a look on a one-component part machine, or micro-molding, or combined maybe?
Of course we can. We started with one component molding here and we still have a lot of applications left. Where we are heading to is a one component and micro-molding part in the same time.
You mentioned product range and applications. So which are the main markets, the main applications Stein delivers to?
As I mentioned, the multi-component product range is the fastest growing range we have right here. So automotive is big here. We have the sanitary, the industry, the coffee machine parts, as well as healthcare and baby care. We have tools from 1 cavity up to 128 cavities. Quite significant is the output. With the 128 cavity tool, we will be able to perform or produce more than 600,000 parts a day. That is quite significant. And as we can see here, we are now at the 1 component micro molding part. Is a seal cover for a micro switch, and it's a 64 cavity tool. And the special thing about that, all 64 parts have a weight of only 1.45 grams. So one part is only 20 milligrams. And it's a self-designed needle system where we have no waste for runners or screw. So all material will be used only for parts.
And what do we see here, Silvio, on the screen?
We need to make sure that all parts are taken out of the tool. If a part is remaining in the tool and you do the next cycle, you will have a quality issue with the next part. And we do this with an indirect test. We test the presence of the part on the gripper, and we do it with a heat detection camera. So a heat detection camera is quietly independent from light. So you can see here the part is warm.
Yeah.
And the heat detection camera is actually counting the hot spots. And if you have 64 hot spots on the gripper, you can be sure that the tool is empty.
Really, really amazing. Thanks a lot, Silvio, for the overview of technical production. Can we also have a look in our clean room? Is that possible?
Of course.
Thank you.
We are now in the clean room. The clean room area actually is a highly filtered area, and we run here under class ISO 8. ISO 8 means that we have not more than 100,000 particles bigger than half a micrometer on 1 cubic foot of air. We have 22 injection molding machines, and as stated before, we have 1 component molding and 2 component molding. Going to one machine and see a membrane which is used for the milk pump, so it's baby care. On the second floor, we do the random inspection, post-cure, washing and packing. And the clean room on the second floor, we run under ISO class 7. And 7 means we are 10 times less particles than in clean room ISO 8. Hello Caroline, I'm back from the factory tour in the clean room here.
Super. Thanks a lot for the insight, Silvio. And we are now going to our last step, which is the quality department. Last stop of our today's manufacturing tour is our quality department. Hello, Vecchi.
Hi, Caroline.
Can you please explain us a bit what we see here?
So we are staying here in front of a CT tomography unit. With that we have the possibility to do a full measurement in very quick time. We have the advantage to support our engineering and our operation very quickly with high precision data and to give them the right feedback with high quality. With that we have the possibility to short the industrialization time for product realization. One side what we have to consider is product realization, and the other side is product controlling during operation for mass production.
Okay.
And for that we are using multi-sensor technologies. As you can see here, a technology which are working with 3 sensors. It means a bottom, a camera and a white light sensor, where we are able to give in real time, almost in real time to operation feedback, where we are staying with the quality level based on the requirements from the customer.
Especially, we would assume, related to safety critical parts
Of
and really
course.
critical requirements of the customer we solve.
This is very important, this real-time feedback with the high quality data. Here we can see also another part. This is similar. As you can imagine, if you have to measure today these parts, you need this multi-sensor technology, and this is just possible with such a kind of technologies. Till now we had the possibility to measure different parts, very complex parts with this multi-sensor, but what we couldn't do was tiny parts, high transparent parts. That was not possible. And we have now the latest technology to do that. And I would like to show you
Let's go.
Let's go. As I mentioned, Caroline, I want to show you this multi-sensor technology where we have the latest technology, what you can have today. We are able with this technology to measure 3D methodic, high transparent parts very fast and very quick. As you can imagine, healthcare medical parts are in the most of the time very tiny parts with very complex geometry. And this is the best possibility how you can measure today, touchless, with the high precision.
Excellent. Thanks a lot, Betsy, for a really good overview of our quality capabilities here at Trelleborg Stein am Rhein. This was the last step of our manufacturing tour. We hope you enjoyed the insights and the overview here of our manufacturing site at Trelleborg Stein am Rhein. Thank you and goodbye.
And we just flew all the way back here to Stuttgart, Germany, where we're also joined by Jarno Burkhardt, the general manager of our Stein am Rhein plant. Jarno, what a special, interesting site. You must be very proud to work there.
Yeah, it's really a nice place. We put a lot of energy and effort into that, and I hope it's also been visible when we show this little clip.
Absolutely.
Yeah.
So we're going to go to some audience questions real quick. What are the biggest trends in LSR technology, and how are you as a Stein am Rhein site focusing on them?
What we see as the biggest trend is actually a combination of two. Everything becomes smaller, miniature micro molding, but also multifunctional, so two-component or multi-component parts with the ambition that they should come smaller and smaller. So it's not only the processability, it's the entire process setup, automation, the handling, the measurement, the packaging. So everything needs to follow this trend. So this is what we are seeing really as a strong development and market need.
Fantastic.
Yeah.
Next audience question is, how can you support a project in the US with all the knowledge that you have in Switzerland?
Actually, there are two ways to do that. I mean, first of all, we always cooperate very closely with our sister sites. So we would probably help in laying out the tool, the design, make suggestions for the automation. And then we have two ways to do that. We can maybe build the tool in Switzerland, set up the process, train our colleagues, and then transfer the production. Or we do it like we support or collaborate with our colleagues in the US, and they produce the things locally, whatever is the most feasible approach for the program.
Absolutely, and that site selection is very key. We have production in the US, production in Switzerland, and production around the world too, so that's great. I guess really quick, what do you see as the main strength of production at the Stein am Rhein site?
Actually, it's the engineering capability, I would say. So our understanding of the application, the media, the functionality of the part, and then the ability to design a tool and the process around that finally the part hits exactly the requirement of the customer. The engineering capability is probably our strongest skill.
Fantastic. Well, Jarno, thank you so much for the virtual tour of your site, and we greatly appreciate it, and thank you for joining us today.
Thank you for having me. Thank you very much.
All right, so now I want to move a few seconds into the concluding remarks here as we go and finish out our session today. First of all, thank you for joining and thank you for taking time out of your day to learn more about silicon technology and how it can support medical device innovation. I'm going to ask our business area president, Linda Morawski, to rejoin us here on the stage. We'll have a few concluding remarks. Linda, so what did you think about the sessions today?
Wow, I mean, what the capabilities that we have as an organization. Certainly we've set ourselves up for success with our customers. You can hear a lot about our engineering and our technical capabilities, and all of that comes from our people. So while we've purchased different companies and we've made acquisitions, we've put people together, we've developed a lot of the technologies in-house, it's all because we have the right people in the right places for us to support our customers and take their technologies or our technologies together to the next level.
To the next level is right. Well, that's a great way to wrap up the event here, I think. On behalf of me, Trelleborg, and the entire team of Connects, we want to go ahead and thank all of the production team that supported with us today. And thanks to you, our customers. Thank you for your interest in the topic, and thank you for continuing to make an impact on patient lives. We're Connects. Have a great day.